Hello guys, welcome to this session by ERC. Uh, so this session will be about an introduction to programming in general and mainly programming in Python. So I'll just wait for and verify whether we are live, and if anyone can confirm in the chat whether there is sound and everything is visible properly, then I'll start. Cool. Okay. Yeah, okay. So looks like everything is fine. So once again, welcome everyone to this session. I'm sure almost everyone in college has thought that they'll be involved in some sort of programming some or the other time. So, and if you're in for your first year, then definitely, and you have not experienced programming yet, you'll definitely, it's quite likely that you'll try at least some form of programming. So let's get started with what exactly programming is. And the session is mainly focused towards an introduction to Python. But before that, we feel that it's necessary to talk about what programming is. And at the end, like, you can obviously post all of your doubts in the live chat, and we'll answer them. Um, but at the end of the stream, we'll also have breakout rooms where you can ask specific doubts that you have across the session. So yeah, let's get started. So one important thing which I feel you should do when you're doing anything is ask two questions. So the one is what, and the second is why. So the first, we're doing thinking about programming right now. So what is programming, and why are we interested? Why do we care about it? Like, not just because there's a huge demand or something like that, but some a bit more fundamental reason as to why programming matters. So uh, firstly, what is programming? So very abstractly and very uh, what do you say, in very simple terms, programming involves rather data manipulation. You have some form of storage of the data, you have some form of input, and then you have an output in your system. And basically through programming you are executing some or the other useful tasks or instructions. So in short, programming is execution of instructions that involves data manipulation, storage of input, storing data, and obviously interacting with your environment. So you are having some sort of input and output, and you are doing something useful with a series of instructions. And why programming? So why does why do we do programming? So it has advantages because we have developed electronics, and we have developed computing systems which have very good speed and accuracy, and they can perform intense calculations. For example, like you must be viewing this stream on either a laptop computer or a mobile device, and that per every all of such devices are performing a lot of calculations in a very less time. So that's why it's important. And we live in a world of machines, and we are automating a lot of tasks. So for achieving that, you need programming. So that was about why programming. So let's just go over what sort of approach you might have towards programming. So like I said, programs are instructions which you tell your computer. I'll go over how you tell your computer, but you tell your computer to execute those instructions. And there are a few patterns which we can identify. uh, some of them you want certain instructions to always execute. For example, when you switch on your computer, you want it to always go into your, like, load your operating system and basically have a startup screen ready. So you need some instructions that you want to be executed all that every time. Then there are some instructions that you might want only in a specific case. So let's say, like, it can be anything, like opening a file. So if you open a file, that's not exactly something that you do all the time, right? So that's a special purpose sort of instruction. It's a very broad classification, just trying to give you a abstract idea. Then we have certain instructions that you want to do in a loop. So let's say you want to add numbers. So let's say you want to add numbers from, let's say, 1 to 100, or you want to cycle through some photos in your gallery in a slideshow, let's say. So you're doing things in a loop in which basically you're doing one thing after the other, and you are basically having a loop of sorts. And the fourth is you have conditionals. So you want to check like you want to check certain conditions, and accordingly you want to do things. So this is a very broad classification of the types of instructions that we have, and there are a lot more. So the three dots are standing for that, so there are more as well. But broadly you can say that these can be certain classifications. And let's just go over a very abstract model of what the computer looks like. This is very, very basic. It doesn't have any details. So as a programmer, you write in some language. And so you might have heard of programming languages like obviously Python, C, C++, Java. There are a lot of languages. So they mostly have words that are, you can interpret them in some form of English, and you can make sense of them in our languages. So you write a code in that form. Then there is some converter, obviously, because the machine cannot understand English or directly the language. Let's say you have some statement like print something, so the computer directly does not recognize what that means. So there is some converter that will help you to convert your language into a language that the machine understands. And what that is basically, it's a sequence of bits. So we'll talk more about what that is. But you must have heard the words binary and machine language. So basically your computer is a very, very advanced, like has lots of circuits. And it's basically electronics. So you have to convert your English sort of language code into something that the machine understands and it can execute. So this is a very rough model of what might happen there. And yeah, so we talked about bits. So that brings me to data. So everything like in a computer is based upon data. And everything that you have, or any sort of interaction with the environment is going to be stored in the form of data in your computer, which it can manipulate, process, and run its programs over. So data is, in very simple terms, it is a sequence of bits. So bits is ones and zeros, a string of ones and zeros that we have assigned certain meaning to. So for example, if you look at this bit sequence, so one of the meanings of this bit sequence is ERC. This stands for E, this stands for R, this stands for C. So that is just one in ASCII codes. So you'll get to know more about what ASCII codes are. But basically data is bringing some real world information and converting it into, a string of bits which the computer can process, because computer has electronics and that operates on voltages and currents. So that's why we use this system. And yeah, so that's basically data. And now, because we have data, that brings us to data types. So you have different forms of data from the environment, and you want to process them accordingly. So that's why you have some broad classes of data which are called data types. So integer, characters, floats, string are some very basic primitive data types, and using these you can build more advanced data types. But under all of this, there is a string of bits. So you might want, this is something that is very appreciable, and our computer is designed to you know uh, manipulate bits and give us wonderful results. So for example, this particular sequence, right? So if you interpret it as an integer, it's 69. As a character in ASCII codes, it is E. So that was a very basic, just a simple example. So that's it basically. I wanted to give you a very brief idea about what programming is, and sort of what do you say, a deep level thinking about what is exactly happening inside. So obviously it's an introduction lecture, so we won't go too much into details. And I'll wait here for any questions if there are. Otherwise, we'll move on to Python. It's fine if you do, like, there are no questions. Later on, like as we move on to Python, we'll have more detailed stuff that you can ask questions about. Cool. So that was it from my side. Uh, Now Dhruv will take over and he'll teach you Python.
Yeah. So am I audible? Yeah. So I guess there was a minor mishap. So I'll start again. So hi, I'm Dhruv Poddar, and I will be taking the session on Introduction to Python. Python, you will learn in this session. You will learn the basics of how to interface with a computer using a basic programming language, and you will also realize why instead of just using pure electronics, we use a programming language. So yeah, let's get started. So Python is a very easy and simple to learn and very powerful programming language that was created by Guido von Ross on February 20, 1991. It has an extremely huge range of applications ranging from robotics to machine learning to finance, and almost any field that you see, it probably has some sort of a Python app behind it. Um, so yeah, so let's talk about how we will be running Python. So using the best way to run Python without the hassle of having to install stuff is using a Google Colab notebook. This is based on the Jupyter Notebook platform and was made by Google. So here's the link. It will be put in the chat soon, so y'all can join in. I have a Jupyter Notebook locally on my device that I will be sharing, and I will be explaining some of the code examples via that. So I'll give 2 minutes for everyone to get the Jupyter Notebook running up, and then we can continue. So yeah, I assume everyone has the Jupyter Notebook set up. If not, you can just watch for the time being. We will have a doubt session in the end. If you have any difficulties, you can ask during that. So yeah, so let's talk about data types. Data types, as the name suggests, is the type of data, or you can think of it as the in which you make the computer understand what type of what those bits, what those zeros and ones actually mean. Like for example, the same sequence of bits, as Atharva explained in the previous session, was that the same sequence of bits can represent the number 69 or the letter E. So how does the computer differentiate between when to use the number or when to use the letter? So that's where data types come in. One thing special about Python is that when you write a variable is basically a name that is given to a set of data. So when you let's just say when you define a variable, you don't need to explicitly state the data type. The reason for this is that Python is a language that does a lot of processing already on the in the background during execution, and this makes stuff easier to understand for the programmer, but often it is slower when running on the computer. So here are the basic data types in Python. The text type, that is for words and letters, is str, or as some of you who have studied the other programming languages might know, string. Then there are three numeric data types, which are int, float, and complex. Int is the integer data type that you use for numbers, which are like positive, negative, and zeros. Float is the decimal data type. So you have like numbers like 10.5 and minus 10.5 or 0.00, stuff like that. And complex is used for complex numbers, that is a plus bi type numbers, that is in the complex plane. And then we have the Boolean type, bool. So the Boolean type is the data type that is used to represent. It only stores two values and it represents true or false. It's basically like a bit which is one or a bit which is zero. Um, so yeah, the keywords that I have shown can be seen when you run the code in the Jupyter notebook. So yeah, so for example, I have a statement a equals 10. I have defined a to be 10 here. And when I run this, okay, so yeah, I forgot to tell everyone how to run a Jupyter notebook. Once you have the code written and in a cell, you can just press Shift Enter and it will automatically run the code and give you the output beneath the cell. So yeah, moving on, as you can see, once I write the code and I have a set of written codes over here. So yeah, as you can see, if you write just a equals 10, this puts the value of 10 in a variable somewhere in the computer's memory named as a and puts the value of 10 inside that. And this is a neat method that you can use to get to know the type of a variable. So as you can see, if I put a equals 10, it automatically Python tells me that the type of the variable is integer. Now, in the next line, if I run b equals 10.0, that is, I add a decimal point, then Python automatically understands that it is of type float. As you can see, this method will return the type float over here. And if I add a double quotes or a single quote, so for example, right now I have double quotes, right? So if I run this, as you can see, the type is str. And if I replace these double quotes by single quotes, the type obviously is still str. There is no difference between the two. You can use each of them whenever you like, however you like them. So next is the Boolean data type. So Boolean can have only two values, as I told earlier, true or false. So this is the true value, and yeah, it's bool. Now if I make this false, it still returns the same value. Another thing about the Boolean data type is that it is often used as a checking statement. That is, for example, here I want to check the equality of two statements. So I have d is a equals b. Now since a is 10 and b is 10.0, they are obviously the same. So if the double equals is a statement which returns, well, which compares the two values on the left and right side and returns the Boolean value. So this will obviously be of type Boolean, and if we want to see whether this returns a true or false, I can just replace this type by just d and execute. And yeah, you can see, since a is 10 and b is 10.0, Python automatically converts the 10 to 10.0 and then it compares them. So yeah, we get a true value. Moving on, let's talk about the types of statements in Python. So Python has three types of statements: sequential statements, conditional statements, and iterative statements. I will explain more about them as we go on. So yeah, um, let's talk about some data structures in Python. So Python has three types of built-in data structures, that is the list, the tuple, and the dictionary. I will Let's talk about lists first. So lists are basically like an array or a series of memory locations, each of which contains some amount of data. The list is represented by a pair of square brackets. Just a note, the type of bracket that you use when defining any data structure in Python is important. You can't just interchange them whenever you like. So yeah, so let's talk about lists for a moment. So yeah, this is the list. So that's how you define a list. For example, colleges, and then I have placed data separated by commas in each place. Uh, so yeah, so this list has three members. That is, one is the string bits, the string IIT, and the string IIM. And if you want to print, obviously just write print and then inside brackets colleges. So this will print the list. Now the neat thing about lists is that you can store a lot of data in just one variable and access it using an index. So an index is basically the location count wise of that member. So for example, okay, so obviously computers start then counting from zero, right? So zero is the index of bits is zero, the index of IIT is one, and the index of IIM is two. Even though you can see it has three members, since the counting starts from zero, obviously the index will be the place minus one. So if I want to print colleges of one, like I want to print IIT, let's say, then obviously I can see it's on the zero and then the first position. So I will just write colleges and then square bracket one. And obviously IITs has been printed. If I want to print IIM, I will write 2. So IIM has been printed. Now let's just say I want to change the value of some member, right? So the same way I want to change IIM into VIT. So colleges of 2, that is the second member, or 0, 1, 2, the second member of the list, I can equal that to VIT and it will replace the value. As you can see, if I print it, you can see that VIT has been put there. Next, if I want to remove a value from the list, sorry, if I want to insert a value at a specified index, right? So directly without using this type of notation, I can use colleges.insert. I will explain what the dot operator is doing, but insert, okay, yeah, so colleges.insert 0 and then Manipal. So what this will do is it will insert uh, another data entry at the start of the list in the before bits. So if I print it out, you have Manipal and then the rest of the list. If I want to remove an element from a list, it's just insert ki jagah you have to replace it with remove. So remove and then VIT, and this will obviously remove the VIT wala entry from the list. So that was lists. Lists are some of the most used data structures in Python. You will be seeing them further in this session when we explain NumPy and Matplotlib to you. So yeah, let's move on. Um, yeah, so the second data structure in Python is a tuple. A tuple is basically like a very similar data structure to the lists, but the only difference is that their values cannot be changed. For example, as I showed in this part, you can change the value of any element in the list at any time, right? I used this in this method of changing the value, so I just wrote colleges of 2 and put it equal to VIT. This the same isn't valid for a list, and lists are usually represented using your normal parenthesis. So yeah, I have defined the same list college using the three same entries, bits, IIT and Manipal, IIM, and yeah, so I can just print it out and obviously it is being showed. Now the method of indexing or the method of getting a value from the list is same as that of a sorry, getting a value from the tuple is same as that of a list. So you can use the same square brackets and then the index. So I get the same value IIT. So yeah, that's all there is for lists. Let's talk about dictionaries. Dictionaries are used to store data that is associated with another piece of data. Like for example, in a real dictionary, you have words associated with their meanings, or for example, in a phone book where you have numbers or mobile phone numbers associated with their names. So this type of data is very easily stored using dictionaries, and dictionaries are represented using a pair of curly braces. So yeah, so this is how you write a dictionary. You this dict is equal to and then the curly braces, and then this is the what do you call it? This is the key and this is the word assigned to it. So for example, the brand is now Ford, the model has been assigned as Mustang, and the year has been assigned as 1964. As you can see, I can store data of multiple data types in a dictionary without explicitly needing to define it. And when you print it out, this is how it looks like. So now what I want to do, let's say, is that I want to access the model of the dictionary, like the model key of the dictionary. So what I do is X is equal to this dictionary, and then in the square brackets I put the name that I want to access, that is the key, so model. And as you can see, it prints Mustang over here. That is, it has automatically fetched the Mustang name from the model ka name. The same I can do is using another method. This is like, if you don't want to use this method of referencing, then you can use a function, and that is just this dot get and then the index you want to put. So yeah, if I print here, I get 1964. So yeah, that is about the data structures in Python. Let's continue our discussion about the statements in Python. So there were three types of statements: the sequential statements, the conditional statements, and the iterative statements. Um, so yeah, So let's talk about the conditional. Let's talk about the sequential statements. So as the name suggests, a sequential statements runs one after the other, like they follow the normal format of reading in a textbook or something like that. So yeah, sequential statements are like very simple. You can think of them as just normal statements. So here I've given the value 10 to a, and then I have created a new variable b, which is just a plus 10, and then I have printed it out. So that's just as simple as that, nothing more to say about it. The fun part about statements come when we get to the conditional and iterative statements. So let's talk about the conditional statements. Conditional statements basically give you a way to form to do a certain action if a certain condition has been satisfied. Just a minute. Yeah, so a conditional statement is used to do a certain action when you have a certain condition that is true or false. So here the Boolean variable that I had told you all about earlier comes in. So if the value of a Boolean variable or a Boolean statement is true, then a statement is executed. If it is false, another statement is executed. So let's see some examples. So here I have a is equal to 10 and b is equal to 20. The syntax is obviously if. Okay, so example of a conditional statement is the if else statement. And yeah, so okay, just a minute, I think there's a font size issue. I'll just increase that. Yeah, so okay, didn't increase. Yeah, so let's talk about the if else statement. So if else, as the name suggests, it executes it executes one statement if a value is true, else it executes a different statement. So the same goes here if a is equal to b, right? So the double, like I said, the double equals operator returns a let's returns a boolean value depending on whether the two values on the left and right are the same. So here, since a is 10 and b is 20, they're obviously not the same, so it goes to the second part, that is the else, and it runs print not equal to a not equal to b. As you can see, that has been printed here. Now let's just say you want to execute multiple if else statements at once, like you want to execute multiple conditions. You want to check for multiple conditions and execute the one which is true. So you use a if else statement, which is basically it checks for it. It first does a check. If that doesn't go, if that is false, then it goes to a second elif statement, and that checks that performs a boolean statement. And if that is not true, then it goes to the else statement. So as you can see, since both are equal, it obviously here it will print a equals b. So a equals b is printed. Now if I instead make this 5 and this 15, so I have checked for the condition that a plus b is equal to 20. And now if I execute the cell, a plus b is 20 is printed. Now if let's just say I make this 7 or 17 or 157 or any number like that, and I execute it, then as you can see, a plus b is not 20. This is the last statement that gets executed. So yeah, that is all there is to know about conditional statements. Let's talk about iterative statements. Iterative statements are statements that make change the program flow so that a certain set of statements are executed over and over again. For example, if you want to print "Hey, my name is Dhruv" 10 times in a row, without the iterative statement, all you would have to do is write print "Hello, my name is Dhruv," print "Hello, my name is Dhruv" 10 times. A better way would obviously be using loops. So let's see some of the iterative statements that we have here. So here I want to print the numbers in the range 0 to 4. So I just write for, which is a loop statement. In for I is, let's just say, a variable I've just defined in the range 4. So what this does is it tells the compiler I want to check as long as there is a number in the range 0 to 4, it will print it. So and then if I run it, so 0 1 2 3, so 0 1 2 3, and as soon as it reaches 4, it stops. This statement, what this statement is doing is checking if I variable has the value which is in the range 0 to 4, and if that value is in the range 0 to 4, it executes this statement. And then after executing this statement, the for loop automatically increments the value of I, so that now if I was 0, it becomes 1, 2, and then so on. You can also use loops to run through dictionaries and data structures very easily. So for example, as you can see, I have defined a fruits list that is containing three elements. So for x in fruits, so x, each time when the loop is run, it will assign a value from these three values, obviously going in sequential order, to x, and then it will print them. So yeah, as you can see, it prints apple, then banana, then cherry. You can also use the same for traversing through a string. So for example, x in banana, and then you can print x. So it will traverse through each and every character in the string. For example, here it has printed banana. If I want to write any more characters here, I say banana is good, and then obviously, so as you can see, BANANA is good. It traverses through every character in the string, and then it gives a print. You can also nest loops and conditional statements together. So for example, here I have a for loop for which is running in the range 5 to 10, and then inside I have an if condition that checks if I is greater than 5, and then it executes the break statement. So, and then if the condition is false, it executes the print statement. So what this block of code is doing is it is checking that as long as my I is less than 5, it will print I. And what this break statement does is, if this condition is true, break will be executed. And what break does is it automatically moves the program flow execution outside the loop. So if let's just say that my cursor is where the program is, where the interpreter is running. So right now it's over here. It executes the statement, and if it checks if I is greater than 5. If I is not greater than, if I is greater than 5, that is I is 6, 7, 8, 9, or 10, it goes to this line. And then if the break statement gets executed, it directly goes to this line, that is, it goes outside the loop. This is used to end the loop when a certain condition is met. Many times, if you want your loop to finish when, let's just say, you have finished a level in a game, right? So if the level has been passed, it will execute a break statement and it will come out of the level. So that is where the break statement comes in. Another type of loop in Python is the while loop. So a for loop executes a condition with an initial value, and it iterates through it. So every time this value gets incremented. What a while loop does is it just checks whether the statement in front of it is a Boolean true or not. And if it, as long as it's true, it keeps running it. You can think of this in English. So while I is less than 6, do these following statements, right? So as long as this is being true, I will keep doing these statements. So here what I have done is I've printed the value of I, and then I'm slowly incrementing the value of I after printing it, so that this doesn't run to infinity, right? So as you can see, it keeps printing till it reaches 5, and when this condition is false, it stops. Next, as you can see, you can use the break statement in while also. So that's what this code is doing. If we reach a value of 3, we break out of the loop, so it prints till 3. This statement, by the way, is being used to increment the value of I. If I remove this statement and execute the code, it will keep giving me the output, since there is no change in the value of I, right? It's 1 right here. I'm not changing I, so this condition is always true. And as you can see, this is giving me an output that goes to infinity. I can't even scroll till the end. Like, it keeps running. This is what we call an infinite loop. So yeah, um, ignore that error. That is just because I ran an infinite loop. So let's talk about the continue statement. The continue statement is similar to the break statement, except that instead of moving the cursor to the end of the program, it moves it to the end of the loop. It moves it to the start of the loop again, and it continues with the next iteration. So what this is doing is basically it checks. So I'll just modify the statement just a minute. Yeah. So it checks as long as I is less than 6, it increments the value of I. If I, as soon as I is equal to 3, it presses continue. So what this does is basically it moves the program back to the start, or it skips the current iteration, or it skips the current loop. That is, it skips the current running loop and continues with the next condition. So here what is happening is, if you see, it prints 1, it prints 2, but as soon as I is equal to 3, it doesn't print, because here the continue statement gets executed and the program goes to the top on line 4, and then it continues with I is equal to 5. So as you can see, it prints 1, 2, but doesn't print 3, and then continues with 4, 5, and 6. So yeah, that is the continue statement. Another thing that you will find yourself doing very often is nesting loops. That is when you want to run one loop inside the other. So what the program is doing is, if x is in ADG, and if y is in fruits, if both these conditions are being satisfied, it prints x comma y. So it prints x and y together. So as long as, so it this is what this is basically doing, is printing all the permutations and combinations of that you can make using one element from this array and one element from this array. So if I show you the output, it's red apple, red banana, red cherry, then it increments, that is x increments. So it goes to big, and then you can see big apple, big banana, big cherry. Again, it increments, and then it goes to tasty apple, tasty banana, and tasty cherry. Oh, so yeah, moving on. Um, yeah, so that was iterative statements in Python. Let's talk about the classes. A class is a very Okay, so that just a heads up, the thing right now is called object-oriented programming. Some of you might have heard about it. I won't go into the very depths of it because it is not possible given my current time frame. Uh, so yeah, let's start with classes. Think of a class as a blueprint for different objects. Like for example, if you have a cookie, then a class is a cookie cutter. That is, you can use one cookie cutter to create multiple cookies using the dough, right? You press the cookie cutter on the dough and then it creates multiple cookies. You get what I'm going on, right? So in Python, a class is created using the
Uh, uh,
class keyword.
एक minute.
So yeah, let's go forward with that. Just a minute, I think there is some technical issue. Yeah, so I guess the issue has been fixed, so let's continue. So how we define a class is using the class keyword, which is basically like class car, my car. So as you can see, like although the naming can be anything that you want, but think of this, a car can be anything, right? So a variable of my car can be a Mustang, it can be a Honda City, it can be a Civic. So yeah, a class is not a type of object. An object is a type of class, right? So I'll explain this as we go on. So uh, car and then bracket. This statement, what basically the statement is been doing is it creates an object, or it creates a instance, or it creates a let's just call it let's go with an instance. So it creates an instance of the type car, and I can access a variable of that instance, that is Mustang. So my car is equal to Mustang is a property of this car, so that I have defined this in the code. So what this basically is doing is this is actually giving me a way to give the same property to multiple different objects at the same time. So a car can have the name as my car. It can have let's say a type. So type is equal to, let's say it's a four-wheel drive car. So 4WD. And if I want to access the type of the car, I can just write print car and then the type of the car, right? So as you can see, it gives me that my car is a Mustang and it is a four-wheel drive type Mustang. Uh, I will explain a bit more about how you can give different types of variables, different types of properties to the class, but let's do functions first. So, um, so functions are basically a block of organized code that is designed to do a specific task. That is, for example, you can make them do an addition, make them do an addition operation, a subtraction, or stuff like that. Functions are defined using the def keyword, def, and they can take in some values as input and return a value that is as an output. So yeah, so I have created a function here, as you can see. So def my function print hello from a function. You must have noticed that when I run this cell, there is no output. The reason for that is because this function will not run until I have called it. A call, what I mean by calling a function is that I'm telling my computer that when I run this statement, go to this line and execute whatever is under it. So when I run a function call, which is basically just the name of the functions followed by the bracket, I get my desired output, which is hello from a function, right? So now let's talk about the input and output part of a function. So for example, I have made a function, my function, and then I have a function name, and now it will print the function name. So whatever is inside these brackets is the parameter of a function, and you can think of it as the input that you give to the function, on which the function can perform any operation and then give you a result. So when I run my function of Emil, it prints Emil. So as you can see, and then same goes for Tobias and Linus. When I run this, it prints whatever is given, whatever I give as an input to the function name. So I can also write this explicitly as fname is equal to Linus. So what this is doing is, if there were multiple parameters, I could just write fname is equal to Linus. Um, you can see this over here. This is an alternate way of giving an input to a function. For example, since the order over here is child 3, child 2, child 1, but let's just say I only want to specify what child 3 is. So I can just remove all this, and I can execute this. So all I'm telling my function call is that child 3 is equal to Linus. I don't care what child 2 and child 2 are. And if I run that, it will obviously give me an error because child 2 and child 1 are not defined, right? So when I do this, you need to define what child 2 and child 1 are, and yeah, then I get the desired output. It checks child 3, and since I have asked for child 3 over here, it gives me the output. Now, the output of a function need not be given via a print statement. The function can also return a value. Returning a value means that when the function ends its execution, it will put the control back into the hands of the statement that called it. So basically, when I like for example, I'll show you the order of execution. So I am on this line. Let's just say, obviously, since the function won't be getting run because it hasn't been called yet. So the compiler goes from the second line to the third, obviously directly skips the fourth line to the sixth line, and when it encounters the function call, it goes to the function, so it goes to line 3. It notices that there is an input required. It checks that I have given an input here. It uses that input, and then it runs the line number 4. So what the line number 4 is doing is it is giving the return value called which is a, which is this variable, plus 10, and then it is transferring the program control back to line number 6. Now, how do I specify the type of, let's just say key you have a function and you want to return only a variable that is of the type integer. So you use a minus sign and then a greater than sign, and then you write the data type. You can skip this step if you want. So if I skip this step, I can return a value which is of any data type. So a plus 10, if I just put a plus 10.0 over here, it gives me 15.0, which is of the float data type. Even though my input was 5, 5 plus 5 an integer plus 10.0 a float will obviously return a float type value. So yeah, let's talk about variable scope. So you might have noticed that there are some indents every time I define a function, a class, or a loop, right? These indents, as you can see by these lines, there are a certain number of spaces, this over here. So what these define is a function scope, or, sorry, not a function scope, a variable scope. What the scope means is that it is a range of lines or a range of statements which can access the variable. So let's just see an example. So for example, I have a file for loop over here that is just looping through the names I in range this, and then the intent is to print Mustang 3 times. So as you can see, if I just write if I just comment this line out, that is, this line is not visible to the compiler, and I write car name over here and I execute the statement. Just a minute. Okay, so car name has been used. So let me just change the name. So car test, right? And right. So if I want to, let's just say, print car test over here, I have defined the car test above inside the for loop, so it should be visible to the compiler. But if I print this, it will print the sorry, I have to print this, right? Yeah, so I have to put it inside the print statement. Yeah, so it is okay. Just a second, there seems to be let's ignore this for now. There seems to be some issue with the compiler. Let's talk about the dot operator. You might have seen me using the dot operator before in some of my lines. So for example, when I used it over here, or some places, some other places. So what the dot operator basically does, it tells the compiler to refer to the variable that is after the dot operator by looking inside to what is inside the dot, to the left of the dot operator. So what that means is basically if, for example, over here, so for example, okay, yeah, let's look at this example. So when I use the dot operator, the compiler is instructed to look for my car inside the variable car. So obviously, since you can see car ke under there is my car, right? So it's inside it. So it looks for my car inside car. So that is what the dot operator does. And the dot operator is very useful when you want to call multiple functions. So for example, I have created a class called a calculator over here. I have created like four functions: add, subtract, multiply, and divide. And these functions, if I want to, let's say, call the add function, and I have to give an input a comma b. So I have given the input 10 comma 5 to add, and what this does is it checks, for example, when it encounters a dot operator, it goes to calculator. Okay, it goes to calculator over here. Then when it checks what is on the left of the right of the dot operator, that is add, so it goes over here. It executes the input, that is 10 comma 5, and then gives me the output 10 comma 5 plus, which is 10 plus 5, which is 15. So as you can see, it gives me 15. Now if I want to do the same for subtract, multiply and divide, as you can see, 10 minus, so yeah, and then 10 into 5 is 50, 10 by 5 is 2, so yeah, that's how it goes. Yeah, so that is about the basics of Python. I will be taking some quick questions right now. So if you have any questions, you can put them in the chat box. Um, so is a class also a type of object? So a class is not a type of an object, but it's the opposite. An object is a variable which is of the type of a class. You can also think of this in terms of data types. So for example, when I write int a or I write a is equal to 10, the compiler thinks that the variable a is of type int. So when I write this statement over here, where is it? Yeah, so when I write car brackets, what this does is basically it tells the compiler that I have created a variable of the type car called car bracket, or I can just name it, let's say car obj or car object is equal to car and then brackets. So what this is doing is basically car object is a variable of the type car, and I can obviously replace this with car obj. So what is uh, yeah, so what this is doing is basically car obj is a variable of the type car, and inside that variable the dot operator looks for another variable which is my car. My car, you can think of this as a property of the car, right? So car object is storing those properties, and my car is one of those properties that I can access using the dot operator. So as you can see, it runs the same. um, mm, So just a heads up, guys. If you have any doubts related to the code that I'm executed, you can wait till the end of the session. We have a doubt clearing session at the end, and yeah, you can ask your questions over there. For now, you can ask some general programming related doubts. So yeah, so difference between functions and a class. So a function is basically a set of statements that is being executed when it is called a car. For example, if I have a is equal to b plus 10, this statement won't be executed until this won't be executed until I call a. But instead, in this function will be executed as soon as I call my function. If I call the car variable, this won't be executed. I need to call car dot a, and then it will take the value of b, add 10 to it, and then print. So we have some previous value of a over here. So let's use a variable k, and let's just put b equals 5 over here. So k is equal to b plus 4. Sorry, 4 plus 10. So it should print out 14 ideally. So car obj is obviously my object of the type car. And if I ask for k, so car dot k, and it is printing 14. So what this basically is doing is it checks for k, it goes to k, and then it sees that k is b plus 10. So it goes to b, gets the value 4, adds a 10, and then prints it. Um, yeah, so I guess that is all the doubts. I'll now be transferring to Yash, who will explain you the two basic libraries that we'll be going through in this session, that is NumPy and Matplotlib. Um,
Okay, 1 second. Okay, so we'll be starting with Python, yeah, in Numpy and Matplotlib. So what Numpy and Matplotlib are is basically they are just libraries which are like assist you in writing programs. Okay, so this is a little bit more advanced than just basic Python, but it will be a very useful skill to learn if you are proceeding with the mini project. And like it's just a useful thing to like write programs with. Okay, so NumPy is a library which basically assists you in doing operations on arrays and matrices and that sort of thing. Okay, so so what NumPy basically helps us with is making arrays. So first of all, we need to like install NumPy. It does not come pre-installed. So these are the simple installation commands that you need to type in your bash terminal. And so yeah, and if you want to import the NumPy into your project, you need to write import NumPy as np as the first line in your program. So now that you have installed NumPy and also imported it into your project, what we need to do is we need to first create an array. Okay, so to create, so basically what is an array? Array you can think of as just a list. Okay, so as Dhruv explained, list is just a data type that stores multiple values of the same data. So for example, this is a collection of different types of integers. So one is an integer, two is an integer, and this is a array of integer, right? So array is just a term to define a collection of elements of the same type. So if you want to create an array that consists of 1 2 3 4 5 3, and it consists completely of ones, then you write to np.ones 3. Okay, so now what are multi-dimensional arrays? So as Dhruv mentioned that you can create a list out of any data type. But what if you create a list of the data type list? So basically you're making a list of lists. So what you're doing is 1 comma 2 comma 3 is one list and 4 comma 5 comma 6 is another list, and you're just like defining them into a different list. Then this would be called as a multi-dimensional array. Specifically here this will be a 2D array which consists of uh, two arrays, one array being 1 comma 2 comma 3, the second array being 4 comma 5 comma 6. Okay, so we can try running this program, like just a simple thing. So here if we create an array of 1 comma 2 comma 3 comma 4 comma 5 and print it, just a minute. First import numpy as np. So we get 1 comma 1 2 3 4 5 as the print. Now if we print an array of 8 zeros, we get 8 zeros. If we print an array of 3 ones, we get 3 ones. Now create what is a now form. Wait a minute. Just a minute. Okay. Yeah, so 1, 2, 3, 4, 5, 6 is displayed in a matrix form. Now, there are various things that you can do with a NumPy, a multi-dimensional NumPy array. So now you can specify the dimension of the array. So here the dimension of the array is 2 because there is list in a list. We can also have list in a list in a list. That would be a 3-dimensional array, and a 4-dimensional array, so on. So if we want to create a 5-dimensional array, we can just do make a list of 1, 2, 3, 4 and specify that this list has this array has a dimension of 5. So when we array, we will, so basically this has 5 brackets indicating that 1, 2, 3, 4, 5 is a like fifth in the fifth. Now if you want to create an array of zeros in a specific shape, right? So what 3, 4 here says is that the array will have 3 rows and 4 columns. So if you see over here, if I just run this program, so this will have 3 rows and 4 columns, as you can see over here. So the shape is basically the number of rows and the number of columns. Now in a 3-dimensional array, this will get a little more complicated to imagine, but so yeah. So if you say want to make an array of 3, 4, 5, so this will have 3 different lists, every list containing 4 different lists of 5 elements each. Okay, so that is how shape works. So 3, 4, 5 is basically the shape of the array. Okay, so now moving on, if you want to reshape an array, so if we created this array of 3 rows and 4 columns, and we want to reshape it into 4 rows and 3 columns, right? So if we go back to this example, so this has 3 rows and 4 columns. Now if we reshape this, array.reshape is the syntax, and you input the new shape over here, so it will now have 4 rows and 3 columns. Okay, so what this means is we are reshaping the existing array. So if we had 1, 2, 3, 4 over here, so there would be 1, 2, 3 and 4 over here as well. Okay, so now one thing to consider is that if this has 12 elements, right? So this is 3 into 4, 12 elements in total. The reshaped array should also have 12 elements. If it does not have 12 elements, say if you write 5, 3, it will have 15 elements. So that would give an error because the original array has 12 elements. So the reshaped array should also have 12 elements. So if you don't understand multi-dimensional arrays completely, that is totally fine because it's a little bit complicated. So yeah, so now we'll move on to array indexing. Okay, so what array indexing is, just like Dhruv mentioned, if we want to get the third element, we simply count 0 is this is 0th element, this is first element, and this is second element. So if we write array in square brackets 2, then the output will be 3, right? But since NumPy has multi-dimensional arrays, to find the index of a multi-dimensional array, it gets a little bit complicated. So what this 0, 2 over here suggests, so this is a 2-dimensional array, this is a two-dimensional array, and so we need to write two indexes corresponding to every uh, element of the array. So for example, we are printing here array 0 comma 2, right? So what it will do is it will go to the 0th element of the first list. So this is basically a list in a list, right? So the outer list, the 0th element of the outer list is 1 comma 2 comma 3. This list is the 0th element of the outer list. Now in this list we need the second element. So this is the 0th element, this is the first, this is the second. So the output in this case will be 3. We can try running this over here. So so if you just run this, so see the output is 3 over here. Okay, so moving on. So array slicing, what is array slicing is creating a sub array from a given numpy array. So say that you have this list 1 comma 2 comma 3 till 8, right? Now if you want an array which consists of say only 1, 2, 3 and 4, you don't want this rest of the array. So this is where slicing comes in. So slicing basically gives a part of the array, right? So while slicing the array, we need to first specify the start step, that is the start index, the end index, and the step. So for example, in this case, the start index is 2. So 0, 1, 2. 3 is the start index. And the end index is 6. So 0, 1, 2, 3, 4, 5, and 6. So this is the sixth element and this is the second element. So this should go from 2, 3, 4, 5, and 6. Now keep in mind that the element at the end index is not a part of the final array. Also, what this step means is that if the step is 1, you will increment once. So you will do 2, 3, 4, 5, and 6 will be the part of the subarray. And for example, say if you have a step 2, right? If you set the step as 2, then it will take this element, skip this element. So it takes every alternate element. So it takes 2, it takes 4, and it takes 6. So the output would be 2, 4, 6 if the step is 2. So we can try running this. Uh, so wait, okay. So 2, 6, 1 gives the array 3, 4, 5, 6. Okay, so now if we change the step to 2, it will only give us 3 and 5 because it's skipping over this element. I made a mistake here. This is the second element, 3 is the second element, and 2 is the first element. Okay, so now I would suggest that if you like, I'll just explain briefly how slicing in a 2D array works. So so if we have this 2D array, right? So this array consists of, this is one array, this is second array, this is third array, this is the fourth array. Okay. Now 1 to 3. And also if we don't specify any step, the step is assumed to be 1. So we are taking elements from start index 1 till start index 3. So this is the start index 1 and this is the end index. But since we don't count end index, we'll just take these two arrays. Now in these two arrays, we are taking elements from 0 to 2. So this is the 0th element, this is the second element. So in the end, we're printing 4, 5, 6, 7, 8, 9. We can check. Wait. Yes. Also, the end index is not considered, so 6 and 9 would be not printed, so it will just take 0 and 1, 4 and 5. Okay. Just share. So this is 4, 5, 7, and 8 will be printed over here. uh, if we want to create a new array which has the same elements of the old array, right? So what we want to do is we just want to copy this array over here into a new array. So one method you can do is you can just write array copy2 equal to array. But the thing is that if you write this statement, the third line over here, what will happen is that the same, like if you change array copy to, the same changes will be reflected in array as well, because they are the exact same array, and any changes you do to array will be reflected in array copy to. So they are not independent arrays. But if you want to make an independent array, you need to use the function copy. So if you do array dot copy, it will create a new array. So if you change array copy 1, it will not change uh, the original array, that is array. So I'll show this. So if you have so what this program is basically doing is it's first changing array copy 1. So this is the copy, and then it's printing the original array. Then it is changing array copy 2 and then printing the original array again. So as you can see, the second time it is printed, the third element is changed to 3. So we didn't even change array, we just changed array copy 2, and the original array was changed. So that is why when we're duplicating arrays, we use array dot copy instead of just using simple equality. Now there are a lot of methods in NumPy. There is concatenate. So what this does is it merges one array with the other array. There is also split, which splits one single array into 3 different arrays. There is search, where it searches. So these methods are kind of complicated for you to understand. Like, and also what you can do is you can search different methods of the NumPy library and just see what all sort of methods are there. So these are just few of the methods that are available on the NumPy site. And there is also summation and product. So one thing to note is that this is a very useful function, sort. So what sort does is it sorts any array into ascending order, right? So any given array will be sorted in ascending order, and it will be stored in new array. Okay, so yeah, uh, I would say also the thing is that you can perform any sort of manipulations with the array without using these methods. These methods are just to make your life easier, but you can choose not to use them and perform essentially the same things. So yeah, so I would not be covering these methods. If you're interested, you can check them out. I'll have this link uh, copied into chat. So do you guys have any questions from NumPy? Okay, if there aren't any questions, I'll move on with Matplotlib. So yeah, so first we'll look at how to plot lines in Matplotlib. To plot lines in Matplotlib, all we have to do is use this function. So this is plt.plot. X points is a array which consists of all the x coordinates. Y points is an array which consists of all the y coordinates. This P over here indicates the color code of the line, and this indicates the line width. So if you say, I'll just run this once. Okay, so first we'll import matplotlib.pyplot. Now we have this numpy array 0, 6 and 0, 250. So what it's doing is it's plotting 0, 0 over here, and it's plotting 6, 250 over here, and it's joining them by a line, and here M stands for magenta. Okay, so this just created a simple line from 0, 0 to 6, 250 of the color magenta onto the matplotlib graph. We also need to use a plt.show statement after this, but Google Colab already does that for us, so we don't need to use a plt.show over here. But in your programs, you must use a plt.show to visualize this graph. Okay, so there are different kinds of color codes on this site. I'll share the slides later. So, and marker codes are also given on the matplotlib site. So there are different functions that you can use in matplotlib. So for example, like plotting points and joining them with a single line is already as powerful as it is. You can like show all kinds of shapes just using a simple line, plotting 2 points and joining them with a line, right? You can draw all kinds of uh, trees, and you can do almost anything. But matplotlib also provides some useful functions. So you can label your x coordinates. So sorry, you can label your axes. So if you say plt.x label x coordinate, it will uh, name, like it will show the x coordinate as a label in the graph, and if you put y coordinate, it will show y coordinate as a label to the graph. So I'll just show it. So if I label it, so this is the x coordinate and this is the y coordinate. Okay, now if we want to create a grid, so we just do a plt.grid. We input the color, which is green. We choose the line style, what type of line we want, what type of line width we want. Also, different types of line styles are available on the matplotlib site. So I'll just run this code. So if you do a plt.grid, it just creates a grid of line width 1, and yeah. Now if you want to create we'll tackle subplot a little bit later. Now if you want to create some sort of scatter plot, so what are scatter plots? Scatter plots are just plotting points onto a graph, and like just helping us visualize some sort of point data. So we have an x array and we have a y array, and we label the x coordinate and y coordinate, and just use the command plt.scatter x comma y, and we also can choose the color as a hexadecimal code. So I'll run it and show you. So this is the scatter plot that we obtain. So it just basically does two plots 2, 21, 2, 13, 8, 15, 1, 18, 15, 4, and so on, 8, 8, and so on. So this is what the scattering does. So now what subplots are, what you can do with subplots is basically have multiple graphs into a single graph, right? So if you want to show two graphs side by side, what you do is Like for example, you want to show two graphs in one single row. So the number of rows is 1 and the number of columns is 2, right? So I'll just so wait a minute. So for example, we want to print this, right? So there are two graphs side by side, and uh, the first graph is both the graphs are in one single row and there are two columns. Okay, so what we do is we create a plt.subplot. uh, this is the number of rows, this is the number of columns, and this is the index. Here one thing to keep in mind is that index starts from 1 and not 0. So if we write plt.subplot 1 comma 2 comma 1, and then we say create a grid as we created over here, create a grid, and then we plot 2 points and join them with a line onto this plot. So what it does is it goes to the first index and creates a graph with a line and a grid. Now if you want to create a second subplot, you just change this index 1 to 2 and you have another graph over here. So we fill this graph with, we choose the X label and Y label, and we have scatter plots over here. And now these scatter plots basically uh, plot the points as we did before in the color that we have provided here. And the scatter plot just creates another graph over here. Right, so I'll just show you some examples. Like, so I have this RRT code over here. Don't get intimidated by the size of the code. So this plots RRT, uses the RRT algorithm and plots a plots a path from the origin to the goal. Goal is 10 comma 10 and origin is 1 comma 1. I think, yeah, it's 1 comma 1. So it plots a path, and this is how you visualize it. And this is a RRT star algorithm. So the origin is over here and the goal region is the small green box. And there is one more type of path planning. So this is the origin and this is the goal. So these were just some examples of how you can use Matplotlib in path planning. If you have any questions, so there are resources available in the slides. If you have some questions, you can ask them. Okay, cool. We'll end the stream then.